On this page, we introduce a very important concept called modular design. In my opinion, this is one of the concepts most closely related to operations management. The reason is simple. In today's market, customers want more and more variety and customization. However, higher product variety usually makes production less efficient. Batch sizes become smaller, processes become more complex, and costs increase. So modular design is the key to resolving this tension. It allows firms to offer high product variety without significantly increasing cost. This is the core advantage. The question is how this is achieved. Okay? At a basic level, modular design enables variety through mixing and matching standardized modules. Instead of redesigning an entire product each time, firms can combine existing modules in different ways. Because these modules are designed to fit together easily, they require minimal additional integration effort. As a result, firms can reuse standardized modules, parts, components across multiple products, and sometimes even across product lines. This is why modular design balances cost efficiency and with customer choice. Okay, a relative small number of components can generate a large number of product combinations. Common examples include IKEA furniture, which is highly modular, and McDonald's menu items, where many different combinations are created from a limited set of ingredients. Customers experience variety, while operations benefit from standardization. To illustrate this with a more complex product, consider a car. Suppose a company offers 5 body styles, 6 colors, 2 engines, 6 wheel designs, and 5 interior options. In theory, this already creates 1,800 possible product configurations. If these features were not modular, the firm would effectively need to design and manage 1,800 different products. With modular design, however, these options can be combined efficiently to create customized products without redesigning the entire vehicle each time. We can also understand modular design more closely or clearly using the QFD framework on the last page. If a customer attribute is primarily affected by one specific subsystem, that feature is modular. In contrast, if a customer attribute depends on many interacting subsystems, that design is not modular. In a car, for example, features like the audio system or seating options are modular. Customers can choose basic seats or premium leather seats with advanced features, and those choices mainly affect a single subsystem. These options are easy to add or remove. On the other hand, components like the engine are not quite modular for real-life car, okay? So the engine affects multiple performance dimensions, such as noise, such as acceleration, such as handling, such as overall driving experience. These characteristics depend on interactions among the engine, among the transmission, suspension, and even body structure. This is known as an integrated design. Okay, integrated design is the opposite of modular design. Okay, many products combines both approaches. Okay, so for example, easier to understand spectrum of design is computers. Desktop computers and gaming PCs, they are highly modular. Okay, laptops are partially modular. Components like memory and storage can be swapped. Screens and keyboards are more integrated, but it requires at least a decent level of customization from the supplier. Okay. On the other hand, smartphones, tablets, by contrast, are highly integrated products and with very limited modularity. Okay. So the key takeaway is that different products and different customer requirements call for different degrees of modularity. From an operations perspective, modular design is a powerful tool for delivering customization efficiently. Okay, that's a trick. But it is not always feasible or desirable for every product or every feature. Okay. Last but not least, let's talk about sustainability consideration in product design, often referred to as design for environment. Okay. On this page, I want to focus on the main approaches to achieve environmental sustainability, especially from an operations perspective. Okay. These approaches are commonly summarized as the three R's: reduce, reuse, recycle. Importantly, these three options follow a clear priority order. Reduce is preferred over reuse, and reuse is preferred over recycle. Okay. The first approach, reduce, focus on preventing waste and pollution at the source. This means designing products that use less energy, fewer materials, or less packaging from the very beginning. For example, reducing the amount of plastic in a product or design a lighter product directly improves sustainability at its roots. Okay? The second approach is reuse, which applies after a product reaches the end of its initial life. Okay? Reuse include activities such as refurbishing and remanufacturing, where most of the original product's structure and functions are preserved. A common example is printer cartridge, which, think about it, it can be cleaned and then refilled with ink and reused with full functionality. Okay? Remanufacture is widely used in industries. For example, automotive industry and transportation. Okay? Components like alternators and generators in gasoline vehicles, they are often remanufactured. And many tires used by trucking companies are refurbished rather than produced from scratch. Because significant energy and resources were already invested in producing these items initially, reusing them is far more efficient than making new ones. The final approach is recycle. Recycle typically involves shredding the product, of course, end-of-life product, and separating the materials and returning them to their most basic form, such as metal, plastics, chemical raw materials. Well, recycling helps prevent waste from ending up in landfills. Much of the energy and effort originally used to shape and assemble the product is lost. This is why recycling is considered the least preferred option among the three. Now let's connect these ideas back to design, product design. Across the entire supply chain, from purchasing and manufacturing to distribution, and then product use and services. And finally, actually, after that is disposal, right? Materials, energies, resources are consumed, and waste is generated. The question is, where is the best opportunity to improve sustainability? Just like many other operations decisions, the design stage offers the greatest opportunity for improvement. Decisions made during design determine how easy a product is to manufacture, to transport, to use, or even after the end of the life, how easy or how cheap it is to disassemble it, refurbish it, etc., etc. Okay, there are many practical examples of this in operations. In manufacturing, packaging materials and pallets are increasingly being reduced, reused, and eliminated. Okay, some firms use slip sheets instead of traditional pallets, removing bulky wood or plastic altogether. Others rely on reusable plastic pallets or recyclable material. Product design itself also play a role, right? For example, beverage companies like Coca-Cola have redesigned plastic bottles so that the neck provides structural support, allowing the rest of the bottle to be thinner and use less of the plastic. These small design changes can lead to significant environmental benefits at scale. The key takeaway from this page is that design is the most powerful lever for sustainability. By considering reduce, reuse, recycle during the design stage, okay? So key thing is consider these three guys during the design stage such that firms can embed sustainability throughout the entire supply chain activities rather than think about them after a product is used, okay, after its end of the life cycle. Okay, so that's about this.